Let's get started with today's topic. Yeah, a quick confirmation if you can see the screen. Yes, okay. Today's our topic is Introduction to Feature Selection. So, what we are doing for a couple of weeks now is whatever topics that were not covered much or we didn't go into depth, we are trying to cover those topics. If you are attending the webinars regularly, by now you must have understood we are trying to get to the mind map, and each and every detail we are trying to cover. So here we have feature selection in CRISP MLQ. After collecting the data, we prepare the data for our machine learning algorithms, as part of which we do EDA, and then we prepare the data and also do feature engineering. This is what we have seen our class, right? In feature engineering, we try to understand how feature engineering is done on numeric data. Now, binarizing, rounding, and all this binning, we have seen earlier how to do transformations. Okay, and if there is any connecting formula between two variables, we can apply that formula on the numeric data and create a new feature. In feature engineering, we are trying to understand the relationship between the features and come up with new set of features, or from the already existing features, or on the existing features you're trying to do some transformations or some changes. That is for numeric data. Coming to categorical data, we know we do transforming the nominal features, transforming ordinal features. Encoding, we have seen encoding where we do dummy coding and one hot encoding, right? Like that, we have seen parts of it. Then we went into text data, where we learned about bag of words and TF-IDF, word embeddings. We have seen all these things. We also know how to do the calculation for similarity. We go for cosine similarity when it is text data. Then we also have seen a feature engineering on image data, right? We convert first, we cannot give the images directly or text data directly to our machine learning algorithm. So we first convert it into the understandable format. Here our raw images are converted to pixels. And then there is grayscaling, binning, all these things we have seen, right? This object detection and edge detection will come later in AI. We didn't see that as part of our data science, but all this will be covered in AI. That is about image data. Now we went into feature extraction in detail with PCA, where it uses the eigenvectors and eigenvalues, try to extract the information from the columns, and it creates PCs, that is principal components. And according to our need, or our requirement, we select the amount of PCs that we want to include in our model. So that way we are reducing the number of columns with PCA. So here what we are doing is we are extracting the information from the features. So that's the name given, feature extraction. Now we are talking about feature selection. We are going to select features. Now when will this be useful? Right, when it is a high dimensionality data, you will have to do feature selection. You don't want to have redundancy, or you don't want to have correlated variables. So that is where feature selection comes into picture. And you want to select the features which are very significant or are really contributing to our model insights. We don't want to include all the features, unnecessary computation. So that is where feature selection is coming into picture. So now that we understood where the feature selection is falling, let's come back to our presentation. Okay, so we already know what is feature selection. We just had top view or just an overview of what feature selection is. When we were doing our data science classes, we know what is a feature. Feature is nothing but a characteristic. To be very simple, each column in a data frame is one variable or one feature of that data. Okay, so in machine learning and statistics, feature selection, also known as variable selection, we call our columns as variables, right? Because it can take different values. That is why the name variable. And it also known as attribute selection or variable subset. These are just other names that are given to feature selection. Is the process of selecting a subset of relevant features. Now, this is what we are concentrating on. We are trying to get a subset of relevant features. And these features, where are they used? After you're selecting the features, they will be used in model construction. Now, the advantages are you will get a good accuracy, and simple models are easiest to interpret. When you reduce the number of features, you will be getting simpler models, meaning the number of features are less. So you will be able to draw the insights easily. Shorter training time, because we have more number of rows in our data. When you reduce the features, it is going to take lesser training time. Enhance generalization by reducing overfitting. You will not overfit your models when you go for feature selection. Then it is easy to implement. Reduce risk of data errors. There is no data errors like redundancy and all. See here, removal of redundancy. Reduces bad learning behavior in high dimensionality. When there is a lot of number of columns, that is when you will go for feature selection, which will help in better learning. Now the techniques. Okay, all this is fine. We know what is feature selection, what are the uses. Now we should understand the techniques. So there are filter methods, wrapper methods, embedded methods. We came across the one or two methods when we were doing multilinear regression, if you all remember, right? Filter, as the name suggests, it is filtering out. Okay. Wrapper method. In this method, we use subset of features to train. So you're getting a subset. Based on inferences of this model, we decide either to add or remove more variables. Wrapper will allow you to make a decision whether to add or remove. Then embedded method. Embedded methods are iterative. So they are repeated in a sense that takes care of each iteration of the model training process. And what it does, it is iterating and it will extract those features which contribute to the training. If they are useful to the model, they will be selected. Rest of them will be dropped out. Okay. Now filter selection is not dependent upon any ML algorithm. Whatever method we are selecting the features, right? So we want, here you are seeing that it will be taken, the model will be taken into consideration, whereas in filter method that it is independent of the algorithm. So these are the different techniques that we have. Here is the filter method. So here we are removing. Filter means removing, right? What are you removing? We are removing constant and quasi-constant features. Constant means zero variance. Quasi means near zero. So we want to just remove those type of features. For that, we have univariate method. So single variable you are removing and trying to understand if it is constant or quasi-constant. Right, univariate feature selection methods. Now it will use tests like ANOVA and then decide which one to remove, which one not to remove. Right, F-test, ANOVA, all these are our statistical parametric tests which we can use with our features and then remove them, remove the features. There is information gain. Or we are aware of all these methods. If you remember, information gain we spoke about when we were doing the decision tree, right? So whichever feature is giving more information, that will be kept in the subset. Rest of them will be removed. Fisher's score. Fisher's score again is related to our tests, statistical tests. But here it is talking about chi-square, whereas ANOVA and F-test is numeric. When you have numeric variables, you can go for that. What if it is categorical? You can go for chi-square. Okay. Chi-square will give the correlation between two variables. And we have already learned in multilinear regression, if two variables are having correlation, we can draw one of them, right? Then correlation matrix with heat map. This also is same as correlation matrix, but what you do is you just build a heat map, plot it, and then you have a cutoff. Say if they are related more than 90%, you want to remove those variables, one of those variables. Like that, you will be selecting. That is filter method. Then there is wrapper method. We also discussed about forward selection and backward selection. The forward selection is, say if we have three input variables, x1, x2, x3. Forward selection will start building with single model. x1 it will build, x2 it will build, x3. Three models it will build. Whichever is giving the best accuracy, that will be taken forward, and it will take pairs x2, x1, x2, x3, like that. From this, whichever is the best, it will select that, and that will be the final model. So this is forward, single at a time, pairs at a time. Then if we have another variable, it will take three set of three at once. That is forward selection. Backward selection is exactly opposite of this. This also we have done in multilinear regression. If you remember, we had four variables there, x1, x2, x3. First, we built the basic model, y tilde, x1, x2, x3. And what we do is, whichever variable is giving the least significance, if it is not significant, we just cut out that variable and start building with the rest of the variables. So we have eliminated one. This is backward elimination. There is exhaustive feature selection. This is like best subset selection. It will build all the models, whatever are possible with single variable, then in pairs, like that, x2, x3, x2, x1, x3, multiple models. Then finally it will become build x1, x2, x3. Whichever model is giving the best, it will take that one. 1, 2, 3. Three different sets of models are built. Not three models. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9 models will be built. From the 9 models, whichever is giving the best result, that will be selected. Then there is recursive feature elimination. All these are greedy optimization algorithms. Greedy means they're looking for some kind of information. Okay. So what it does is, in every repetition, it will take the best one and the worst. Okay, so whatever is the worst, it will eliminate. Best one, it will keep it. Then recursive feature elimination with cross validation. It is same like the recursive feature elimination, except that there is cross validation involved. Cross validation, hope you all remember, when the bad data sets are imbalanced, or when you want to do resampling and all, we go for cross validation. So that is how the overfitting also is handled. Now we have embedded methods, which we have already learned. Lasso ridge regressions, which we learned as regularization techniques, right? Lasso will be converting the insignificant column to 0, whereas ridge will be getting it to near 0 value. Insignificant column, it will make near 0. It will not completely eliminate. Then there is tree importance. While building the forest, random forest, we saw that there is something called feature importance. We also plotted feature important plots, which will give how important each of the feature is. So depending upon that, you can select the most important features for that model. So here is a a collection of whatever we learned so far, right, in a single picture. So if your input variable is numeric, and if the output is numeric, then you go for Pearson's or Spearman test. If it is categorical, see, input is numeric, output is categorical, you go for ANOVA, or you can go for Kendall's. Guys, if you have done your hypothesis testing and all the models, this picture will be very crystal clear. If not, then you will have a little bit of, disconnectivity. Now, when the input variable is categorical and output is numeric, you go for ANOVA or Kendall. And if you have input variable is categorical and output variable also is categorical, we go for chi-square as well as mutual information. So this is how the things work, and this is how you have to select the feature selection method, which will give you better results. Okay, so now there is nothing like a best selection model, but all that you have to do is for that specific data on hand, you can try different methods or this combination what we saw in the previous slide, and then decide which method you want to go. Now let's go to code and see how to do that. So guys, the code, the data is already shared to you in your through your mail IDs, whatever you have registered, right? That in that mail IDs, you will receive the code as well as the data that I'm showing you. And every week, that is what we are doing. So you'll have everything recorded. Now, we are getting into the filter methods. In filter methods, we are removing the constant feature. That means zero variance. Okay. So all this we import the packages. Then we are getting our data. In the data, you can see that there is 370 columns in train and test, right? Generally, we are doing the feature only on train so that overfitting will be handled. That is the logic. Okay. Then see here, what we are doing is we are giving the threshold as 0. That means if the variance is 0, you want to remove them. Here we are having 370. So the 319 columns are without a 0. Rest of them, 51 are 0 variance. You can see here, column is 0. 18 column is 0. Second column is 0. 27. Like that, 51 columns are 0. So what we do? We just have to remove these 51 columns. Okay, so that is what we will be doing. And finally, we are getting 319 columns. Whatever are 0 variance, we have removed. How did we do that? By setting the threshold value to 0, we were able to separate the variables which were having 0 variance. Similarly, we do for remove quasi-constant variables. For that, what we are doing is instead of 0, we are setting it to near 0 value. Here you can see it. Threshold value is 0.01. So this time you are getting 263 columns which are not 0 or not equal to 0. 107 columns are near to 0 value. So what you will do in the next step? We will remove 107 and we will just keep 263 columns for our further analysis. If you see this, this is our train data, this is our test data. So using this data, this is X and this is Y. So Y is 263 columns. It is a high dimensionality data set. So our X and Y is ready and our train and test data is ready. So we can go ahead and build whatever model we want to build. So feature selection will come before building the model for filter methods. Okay. Then univariate selection. In this, we have 4 different types, guys. Select K-best, select percentile, select FPR and generic, all that. Today, we will be looking at 2 of them. Select K-best. So what you do here is, in that you are giving what test you want to do. Here it is chi-square. You can also give ANOVA here. And you are also selecting K is equal to 2. So you want only 2 features after performing chi-square. Whichever are significant, only those 2 top significant ones you want to take. Okay, so if you see, before I selected the K2 is equal to 2, we have 150 records and 4 columns. When you apply chi-square with 2, you got only 2 columns as your data set. So we are trying to eliminate the columns which are not significant according to chi-square. Then here we are using percentile. Instead of chi-square and k is equal to 2, you are using chi-square and percentile is equal to 10. So 10%. So here you are having 1797 rows and 64 columns. Out of that, when you ask for 10 percentile, it is selecting the top 7 features. Okay, then Fisher score is chi-square implementation. One thing what you observe is it is similar to k-best. Only thing here you can give ANOVA or chi-square, whereas in Fisher score you don't have choice. You just have to go for chi-square only. So this will give us Fisher score. Here also you can see original was 4. Now you have only 2 because you are asking for the top 2 features. Similarly, ANOVA, right? For ANOVA, you will use F classification. Guys, again, it depends upon the data set which method we are applying. So if this is a classification data, if your Y is in categorical format, then you go for F classification. K is equal to 2. So here also original are 4, but you are asking for 2, so it will give 2. The other F tests, okay, what if it is not classification? You can go for F regression or mutual info regression. This is for regression. And we have used chi-square. We also used F classification. Then there is mutual info classification. Like that, different F tests are there. Depending upon the data, you will have to go with these different tests, whether it is regression or classification. You have to select from that 2 available types. You have to select the test, and then you will be able to do the feature selection. Then correlation matrix with heat map is just like our correlation matrix. Do you all remember how the correlation matrix? The diagonal will be all ones, and the upper triangle is symmetric to the lower triangle. So we are just getting the correlation matrix first, and we are plotting a heat map. In this heat map, we see that there is correlation. We will not look at this diagonal. That is the correlation to itself, right? So in this, you're seeing one of the pairs is having 0.96. Okay, so you can just eliminate the entire column here. Third column we can remove. Same thing, see here. You can drop out that wherever it is. Here also you are using the threshold value, but to check the correlation, if it is greater than 0.9, you want to drop that column. You want to drop it. Okay, here the third column is removed. Then wrapper methods. This is forward method, forward selection. In forward selection, like I told you, it will start off with a single feature, models of single feature. Then it will start building models with pairs, then combination of 3, like that. Here you are having 81 such columns. So how will you specify what is that you want to do? Here you will say forward is equal to true. Okay, forward is equal to true, and you are building the random forest regressor here, and you are giving k features is equal to 10. So 8 out of 81, you are saying you want 10. So you will get those 10 columns which are giving the best accuracies for the random forest regressor model. Whatever are high importance, only those will be taken. Similarly, backward also. For backward, all that you will do is forward is false and features is 10. Okay, when you do that, you are getting the top 10 features for backward selection. Coming to embedded methods, I'm not going into the detail, but I'll provide you with the code because you will have all the code at once for feature selection. This is lasso regression. which we have done as part of regularization, and there is ridge regression, right? We also have done random forest importance when we were doing random forest as part of our ensemble techniques. So I'm just leaving you with the code. These things we have already done in class. Just the last part, embedded methods. Rest of them we discuss now. So I'm giving you the code as well as the data. Okay, guys, feature selection is very important because it has multiple uses. First thing, you can reduce the dimensionality. You will get better accuracies. The speed will increase, right? And you will build the best model by using the best features. You're getting to build the best models and draw insights. If you have 80 columns, drawing insights will become difficult compared to having 10 columns. That is the logic. Okay, so that is all I have for you guys for today. Thank you all.
Hello, ma'am.
Yes.
On doubt, ma'am. If I'm using chi-square test and our test, I can get to only columns. It did not give any column names, ma'am.
I lost you, Sriram. I can't hear you. Others, if you hear, please let me know.
We can't hear him, ma'am.
Ma'am, if I'm using chi-square test and our test for this section, I can get columns. If I give k is equal to 4 or 2, if only gives column values, but it not gives which column that only that name was 0 or 1.
No, your voice is breaking.
Okay.
Akhil, whatever is your email ID, you will get it to that email ID, Akhil. Today it is already shared. Can you please check quickly, Akhil?
No, I can't get it.
Our team has confirmed that it is already given to you. Just check, Akhil. Sorry, Sriram, I can't hear you. Anyone else hear him? Please repeat it.
Hello,
yes, Sandeep.
No, we didn't receive any code, ma'am, about today's sessions.
No, ma'am.
Not yet?
Yes,
not yet, ma'am.
But I got a confirmation that.
Bindu, 1 second. Team, please
Yes,
check
Sarita?
with feedback@360. You will get all the codes. Check one spam also.
Where
No?
to check?
Feedback@360. They will
okay.
Inform them.
Guys, did you listen to that? Please check in your spam and then feedback@360digitmg.com. Tell them that you didn't get the code, mention the topic, and they will get it to you. They will send it to you guys.
Even in this meeting details also they have uploaded, ma'am.
Yeah, I recorded it, right? It will be there on YouTube.
No, ma'am, in this meeting details, Google Meet meeting details. Tell them to see in this.
Guys, can you all hear me clearly? Because whatever you guys are talking, I'm not able to get it.
We are able to hear you, ma'am.
Okay, that is great. Yeah, Prashant, I could get you now.
Yeah.
So yes, the recordings are there. And the recording is there. It will be added to YouTube. Srinidhi, can you quickly confirm if you got last week's code, Srinidhi? You were in the webinar, I know that. So I'm just asking
ma'am, I
you.
didn't
Others
get it.
You didn't get it.
No, ma'am. Today's session also. No, ma'am. No, I didn't. It's just I was checking, but I don't get
any. Please check in the confirm.
I checked, ma'am. It is not available, ma'am.
Okay, so I will talk to the concerned team and get it done.
Me also didn't get it, ma'am. Me also.
Yeah, if one person gets, I'm sure everyone will get. Maybe there is some delay. Let me look into that issue, guys.
2 weeks before then, how to handle imbalanced data. I still did not get, ma'am. How to handle imbalanced data.
I have submitted all the codes and
but
data.
still I did not get it, ma'am.
Yeah, so the problem with Google Meet is I'm not able to copy paste. If you all remember, if you all are following me from last 3-4 sessions or more than that, we tried copying, but because the code is more, we won't be able to copy paste. and there is no share option here. That is the reason we have opted for sending it through your emails. Guys, I'll make sure it is done. Okay, let me talk. Yeah, I understood, Akhil. It is not given last week also. So last week, today, and Sriram is saying even the week before that. Sriram, you had a doubt. I'm able to hear you. Can you repeat the question?
Okay, ma'am. If I'm using feature selection for use that chi-square test, ANOVA test, if I'm using, I can get it if I put in a value k is equal to or k is equal to 4. For which columns are most important, I can get a value only for.
You will get the columns. Rest of the
Yes,
columns
ma'am.
is removed.
I can get the column, but it did not get a
Just like
column
how
name.
we do in lasso regression, right, Sriram? In lasso regression, what will happen if it is not significant? It will become 0. That means the value of those columns are not taken for calculation.
Okay. But it did not give any column names. Only is give a 0 and 1. If given k is equal to, only give 0 and 1. And also did not
Again,
know
I'm
how
losing
to.
you. Guys, anyone able to hear him?
Okay, thank you.
I think he's saying that column name is not given like that, but that is index is given, right? So
No,
through
we didn't
index
go
we get-
into, no, Sriram, it will be given. We didn't get into the that part. Same like lasso, you can just have a plot of all the columns and you will know which columns. The numbers are also given, right, Sriram? Column numbers are given. Index value will be given.
No, ma'am. Okay, now
Okay, I was just showing you that it will drop out whichever are not significant. Yes, you will have track of which are removed and which are there. That information will be given.
Okay.
Do you remember lasso and ridge? How we got the array for coefficients?
Forget them. I can check it once.
What is that,
I
Sriram?
can check with the code. Once I check it, I can.
Okay, I lost you. So anyways, I think I answered your question. We will have track of all that, Sriram. We can plot it, we can print the array of the coefficients, and then we will be able to track the columns. Okay, without tracking, then it will become difficult for us to build a model also. So tracking is there.
Okay, ma'am.
Okay. Yeah. Okay, then. Thank you all. Bye.